Chip model for addition. So that R chip, and we have a B chip, the R is going to be negative and the B chips are going to be positive. We're going to illustrate how using chips we could show that -4 + 3 equals -1. So you have -4, so there's 4 red, +3, 3 black. A red cancels a black. When all the canceling is done, you're left with 1 red, which means it's -1. Charge field, it's exactly like the chips, but instead of saying R and B, you say negative and positive. Absolute value definition. It looks kind of complicated, but what it means is this. The absolute value is going to be X if the X to start off with was positive. But if the absolute value of X, the X had been a negative number, you're going to take the negative of that so you could make it positive. So what this does, it'll give you the positive number if it was a positive number to start off with, or it would put a negative on it so it could switch it to positive. Either way, the absolute value will give you a positive number. This that you see on this side represents a description of the type of number that you're taking an absolute value of. Are you taking the absolute value of a positive number, or are you taking the absolute value of a negative number? Absolute value is always positive because it's measuring the distance, and distance is always positive. Here's an absolute value example. We're going to use the definition we just saw to figure it out. So write in simplest form. Simplest form would be that you don't have absolute value symbols in here. So notice what they're saying. We're dealing with an X that's negative, less than or equal to 0. Concentrate on the less than. So we're dealing with a negative number inside the absolute value. So what does the previous definition say? That you're going to take all of this and replace it with a negative X. So negative X is going to replace this part. Now you continue, combine. The last step will give you a 0. This is integer subtraction, charge field model. How would you represent -3 minus -5? Okay, the standard is that the subtraction is going to mean remove. So you're going to have 3 negative charges, -3, and you're going to remove 5 negative charges. But then we say, well, how can you remove 5 negative charges if you only had 3 negative charges? So what you do is you put into the original problem 2 more negative charges, but since we can't just add negative charges, what you're going to do is really add a 0. So that's why we have a plus minus here, because that's really a 0. Plus minus is 0. But that allows you to put in 2 more negative charges. Once you have all the charges you need, remove 5 of them, and you'll have +2. Simplify. So this is algebra. Algebra is when you have variables involved, letters involved. So right here, we're going to distinguish between a subtraction and a negative. They're not the same thing, even though they look the same. Right here, this symbol means subtraction. This symbol means subtraction. So what we're going to do is going to say plus a negative. That allows you to put the subtraction as a negative symbol. Same here. Notice we move this negative up. Now that you have the negative outside the parentheses, you distribute. So negative times positive is negative. Negative times negative is positive. Now 2 plus -5 would be -3. Or if you like, instead of using a negative symbol, you could write it as X minus 3.